Assalamu alaikum, everyone. Welcome back to Mathematics with Shahab Yaqub. So now this is lecture 5 of quadratics and it's the homework review. This is the table of content from the topical book. The first part, it's about the relation between line and curve. So technically, this is about questions related with discriminant b square minus 4ac. And then the second part, that is about the roots, whether the roots are real and distinct, whether the roots are real and equal, whether the roots are imaginary, and so on. So technically, these two are linked. And then the third thing, that is about quadratic inequality. What's the rule? We will soon see that a sketch based on factorized form, that is a must. So now you would draw the sketch, and then based upon the sketch, you will write down the answer the way that I've explained it. And then the fourth one is let's complete the square. That is the process of completing the square. Whatever is necessary for the completing square method, you should do it. And last but not the least, that is about disguise quadratic equation. Ax square plus bx plus c equals to 0 if the highest power and the second highest power are in the ratio of 2:1. That's a disguised quadratic equation. And I hope you remember we already studied it when we were studying trigonometry. So I have picked out some very nice questions and let's get started. So topic 1, that is about line and curve. And let's look at the first question. It says a curve has equation such and such. So let me underline it. That is the equation of the curve, that is such and such. And the line has this equation such and such, where c is a constant. The first part is find the set of values of c for which the curve and the line meet. Now, very first thing, it does not specify whether it meets at 1 point. It does not specify whether it meets at 2 points. So therefore, the condition of discriminant is b square minus 4ac is greater than or equal to 0. That is the first thing. This is for 4 mark. And let me just copy this thing and let me paste it on the next page, because of course, definitely for 4 marks, you have to work a lot. So now the very first thing is that part 1, make a single equation. 1 over x plus c, this equals to y. Cx minus 3, that equals to y. Equate them to one another. That's the first thing. Second thing, multiply throughout by x. So 1 plus cx is equals to x into cx, that is cx square minus 3x. Write a 0 on this side. Cx square negative 3x negative cx negative 1 equals to 0. Write it in a more refined way. Cx square plus minus 3 minus c, that's the coefficient of x, and minus 1. So this is minus 1 equals to 0. Always a good idea to double check everything. So 1 over x plus c is cx minus 3. Multiply by x, so 1 remains as it is. C into x is cx, cx into x is cx square, good. And 3 into x is 3x with a negative sign. This remains as it is, negative 3x as it is. This goes on the other side, negative. This goes on the other side, negative. And then you take common the coefficient of x. Now let's write underneath it. That is cx square, actually ax square, my bad. So this is ax square plus bx plus a constant equals to 0. Comparing coefficient, a is c, b is negative 1 common, 3 plus c, and c is negative 1. The condition is b square minus 4ac greater than or equal to 0. So minus 1, 3 plus c, the whole thing square, minus 4 into c into negative 1 is greater than or equal to 0. Solve it out. So minus 1 square becomes positive. This is 9 plus 6c plus c square. And this is positive 4c is greater than or equal to 0. C square plus 10c plus 9 is greater than or equal to 0. So remember, this is the simplified version. And let me just push this down. So because I'll be needing it for the second part also. So this is b square minus 4ac greater than or equal to 0. Now keep in mind, this b square minus 4ac is this thing, c square plus 10c plus 9, because we would be needing it for the second part very soon. Right now, whenever you have a quadratic inequality, factorization is a must. So now c square, and this is plus 9c plus c plus 9 greater than or equal to 0. C common, c plus 9 plus 1 common, c plus 9 is greater than or equal to 0. So this is c plus 9, c plus 1 is greater than or equal to 0. Draw the x-axis, draw a curve. The coefficient of c square is positive. Mark down the points. This is negative 9. This is negative 1. And we are interested in greater than or equal to 0. That is this region and that is this region. So this final answer is c is greater than negative 1, comma, c is lesser than negative 9. And since there is an equality over here, so make sure to write it like this. So that is how the first part is done and dusted. 4 marks, 1 page. That is the kind of working you would expect. Now let's look at the second part. Now in the second part, it says that the line is tangent to the curve. It's the same line that they're talking about. It's the same curve that they're talking about. It's tangent to the curve for two particular values of c. For each of these values, find the x coordinate of the point at which the tangent touches the curve. Okay, again for 4 marks. Now, this part is the same. You would equate the two. You will make a single equation. This is what you will get. These will be your A, B, and C. This thing will also be the same, except for the inequality, you will have an equal sign. So now this thing, everything will be the same. Just pick this thing up, c square plus 10c plus 9. So don't increase your working. B square minus 4ac equals to 0. C square plus 10c plus 9 equals to 0. All good. Now this thing is the same. C plus 9, C plus 1, C plus 9, C plus 1 is equal to 0. Therefore, C is negative 9. Therefore, C is negative 1. Is the step all good, all clear? It's the same equation. Of course, you will get the same b square minus 4ac. Now we are looking for values. So now the condition is b square minus 4ac equals to 0. That is b square minus 4ac equals to 0. That is c is this and c is this. Now, what are they asking for? For each of these values, find the x coordinate. Now we have this formula. X is equals to negative b plus minus square root b square minus 4ac, the whole thing divided by 2a. Now, when it says that line is tangent to curve, and the condition is b square minus 4ac equals to 0, so this thing will disappear. So x is simply minus b over 2a. Got the idea? This only happens when we are talking about real and equal roots. This only happens when we talk about line is tangent to the curve. Because if line is tangent to the curve, there will only be one value. So for each value of c, there will be one value. Now, over here, let me pick this thing up. this thing over here because that is based upon this equation. So let me write it over here. A is C, B is -1, 3 plus C, and C is -1. So I'm interested in A, I'm interested in B because I just want to evaluate this thing. So now if C is -9, A is C, that is -9. B is -1, 3 plus -9. How much is that? -6 into -1, that is +6. Similarly, if C is -1, A is -1. B is -1, 3 plus -1. 3 minus 1 is 2, and this comes out to be -2. So now we have A as -9, B is +6. A is -1, B is -2. What are the values of X? So X is minus B over 2A, minus 6 over 2 times 9. That is -6 over 18, which comes out to be -1/3. That is the X coordinate. Similarly, X is equals to minus B is -2 divided by 2 times -1. So this is 2 over -2. This comes out to be +1. They're asking the X coordinate of the point. For each value, find the X coordinate. There will be one coordinate. For one C, there's this coordinate. For the other C, there is this coordinate. So this is -1 and 1/3. Now, let me just check one thing. The critical values are -1, -9. That is good. This thing was good. X is -1, X is 1/3. So now A is C over here, B is -1, 3 plus C, C is -1. We don't need C. So now this is -9. So A is -9. B is -1 into -6. That is +6. This is good. So this is minus B over 2 times A. There was a negative over here. I forgot that. So therefore, -6, -18, that is +1/3. This thing is corrected. And this is minus B over 2 times A. So this minus minus becomes this thing, and this thing is this is -2, it becomes a +2, and this is -1. So, okay, the final answer, let me write it. There are two final answers. One answer is X is 1/3. The other answer is X is -1. So now this is all done and dusted. There was a small plus minus slip that I made. So I hope question 30 is done and dusted. Now let me show you. This question is very similar to this one. Few people have asked this question. And it says this part. A curve has this equation. A line has this equation. State the value of k for which the line is tangent to the curve and find the coordinates of the point where the line touches the curve. So this is exactly like the question that we just talked about. All good, all clear? Now, let me first solve part 1. So part 2, it's very easy. This is just like the question that was over here, which is question number 30, part 2. So I won't be solving this. This is just like question 30, part 2, nothing special. Now, if I talk about the first one, it says a curve has this equation. So now let's focus on the first one. It says curve has this equation, y is equals to 2x squared minus 3x plus 1. Yes, I skipped a question in the middle. I'll come back to it later. And this is y is equals to kx plus k squared. Show that for all values of k, the curve and line meet. In other words, b squared minus 4ac will be positive and greater than or equal to 0, because we don't know whether it meets at 1 point, whether it meets at 2 point. So now when I equate it, then we have 2x squared minus 3x plus 1 equals to kx plus k squared. Make a single equation. 2x squared minus 3x minus kx plus 1 minus k squared is equals to 0. So this is 2x squared minus common 3 plus k, that is the coefficient of x, plus 1 minus k squared is equals to 0. Underneath it, write ax squared plus bx plus c equals to 0. A is 2, b is negative 1, 3 plus k. C is 1 minus k square. Now, what do I need to do? It says line meets the curve, so evaluate b square minus 4ac. So b square minus 4ac, we have to show that this will either be greater than 0 or equal to 0. So let's prove it out. So this is minus 1, 3 plus k, the whole thing square, minus 4 into 2 into 1 minus k square, and greater than or equal to 0. So minus 1 squared becomes positive. This is 9 plus 6k plus k square minus 4 into 2 into 1. That is 8. The minus is already on the outside. 4 into 2 is 8 minus k square is greater than or equal to 0. So this k square and this k square with this negative, this becomes 9k square. And then what do we have? We have 6k. And then 9 minus 8, that is 1, is greater than or equal to 0. Okay, now can this be factorized? I think so. It will be factorized. So therefore, this is 9k square plus 3k plus 3k plus 1 is greater than or equal to 0. Let me add a page over here. So therefore, this is 3k plus 1 plus 1, 3k plus 1 is greater than or equal to 0. And then this is 3k plus 1 into 3k plus 1 is greater than or equal to 0. This is 3k plus 1 whole square is greater than or equal to 0. Now comes a very interesting thing. A linear expression with a square on the outside, this is called perfect square algebraic expression. Now the property is that this can be 0, this can be positive. There is no third possibility. If 3k plus 1 equals to 0, k is negative 1/3 for this value, the bracket square would be 0 square, so it will be 0. Got the idea? 3k plus 1 whole square. Can this be 0? Yes, it will be 0 when k is this. That means for all other values, anything on the inside after squaring, it will become positive. So it can either be 0, it can either be positive, but it will never be negative. So hence we have proven our point that b squared minus 4ac can be 0. B squared minus 4ac can be positive. In other words, b squared minus 4ac is greater than or equal to 0. When this is the condition, the line will always meet the curve. Whether it meets at 1 point or whether it meets at 2 points. So this one was a tricky concept because you have seen it for the first time. So question number 34, part 1, yes, it was tricky. Coming back to this question, that is question number 31. It says the equation of a curve is this, where k is a constant, and find the set of values. Find the set of values of k, that means inequality, for which the whole of the curve lies above x-axis. Now, another very nice question. When I draw a graph, and let me draw two possibilities. That is, let me draw a graph like this. Let me make it more pointed, and let me draw a graph like this. Now, when we are drawing this, the left-hand scenario, the graph, the curve lies above x-axis. On the right-hand side, let me just push this down. because these questions that I took out, they are very, very nice ones. Some people have already asked for it. The curve lies below x-axis. Now, my first question is, what is something that is common between the two? So the common thing is the roots are imaginary. Okay. So the common thing is the roots are imaginary. That means b square minus 4ac is less than 0. Whether it lies above the x-axis, whether it lies below the x-axis, the roots are imaginary. What is different between the two? Now, in the red one, let me just draw this thing red. In the red one versus the green one, what is different? The red one, the coefficient of x square is positive. In the green one, the coefficient of x square is negative. Now have a good look at it. Before we proceed, have a good look at this. All good? Now it says find the set of values for which the whole of the curve lies above the x-axis. Now first focus on the coefficient of x square. It's already positive. All good? That means I just have to work this out. B square minus 4ac is less than 0. So x square minus 6x plus k, that is the curve. So y is equals to x square minus 6x plus k. A is 1, B is negative 6, C is k. B square minus 4ac is less than 0. Minus 6 whole square minus 4 into 1 into k is less than 0. 36 minus 4k is less than 0. This is a linear inequality. It's not a quadratic inequality. Minus 4k is less than negative 36. In other words, 4k is greater than 36. Therefore, k is greater than 9. K is greater than 9. That is the final answer. That is the first part. The second part is nothing special. Find the value of k for which the line is tangent to the curve. This we have already solved in question number 30, already solved in question number 34. We are again solving in 31. This is b square minus 4ac is equal to 0. This is the line. This is the curve. Make a single equation and apply it. All good, all clear. So that first section is done and dusted, which is the most elaborate section. Now the roots, the good, bad, and the ugly. So there are different kinds of roots that we come across. Now for this, we need a little bit of background. And what is the background that we need? So the background that we need for this one is that if I draw a curve and this curve goes like this, okay, let me just change the color because it's merging in. And something like this. Okay. Now we know that y is equals to a x minus p x minus q. That is the factorized form. This is p, this is q, and a is the coefficient of x square. All good? That means if I have the factorized form of quadratic equation, I can get the roots. That means if I have the roots, I should get back the factorized form. That is one way of doing this particular question that is coming up. It says the coefficient of x squared plus px plus q, where p and q are constants, has roots negative 3 and 5. Find the values of p and q. I'm interested in the first part primarily. So I'll write y is equals to a x minus, let me write c, x minus t. I'm deliberately not using P and Q because they have used P and Q. So never ever use the symbols that they have used, the alphabets that they have used. Now we know that the coefficient of x square is 1. That means A is 1. So just write a 1 over here. And then C and D, they are the roots of the equation. So C can be negative 3. D can be positive 5. So therefore, I'll write y is equals to 1, x minus, that's part of the formula, minus 3, and x minus 5. This is x plus 3 into x minus 5 expanded. That is x squared minus 5x plus 3x minus 15. That is x squared minus 2x minus 15. This is your equation. Now compare coefficient with this, x squared plus px plus q. That is equals to x squared plus px plus q. So therefore, p is negative 2, q is negative 15. Have a good look at this question. So this is using the factorized form. The coefficient of x squared is 1. C and D are the roots of the equation. Just plug and expand. Now, someone can ask this question, can we solve it another way? Yes, of course, I can tell you another way. Wherever there is a possibility of another way, which is simple for you people, I'll tell you. So now, part one, alternative way, that is simultaneous equations. So what I can do is that if it has roots minus 3 and 0, that means minus 3 comma 0, the y value is 0, and 5 comma 0. These are two values. So therefore, we have y is equals to x squared plus px plus q, and y is 0. This is x squared minus 3 squared plus p times negative 3 plus q. That is equation 1. And over here, 0 is equals to 5 squared plus p times 5 plus q. That is equation 2. And then you solve it simultaneously. 0 is 9 minus 3p plus q. And this is 0 is equals to 25 plus 5p plus q. Let me make q the subject. So 3p minus 9, that is q. And negative 25, negative 5p is equals to q. 3p minus 9 is equals to negative 25, negative 5p. 3p plus 5p, 3p plus 5p is negative 25 plus 9. 8p is negative 16. Therefore, p comes out to be negative 2. Is that the answer? Yes. And just plug in one of them. Q is 3p minus 9. Q is 3p minus 9. That is 3 into negative 2, negative 9. 3 into negative 2 is negative 6, negative 9. Let me write 9 this way. And this is negative 15. So Q is negative 15. Q is negative 15. So there were two different options of solving this one. And the third part, let me do it, even though we have already done things like that, but in order that there is no doubt left in your mind. So let me do it. Using these values of P and Q. So what are the values? X squared minus 2x minus 15. That is x squared plus px plus q plus r has equal roots. Plus r is equals to 0. It has equal roots. So this is a is 1. B is negative 2. C is whatever constants are left. That is r minus 15, for which equation has equal roots. B squared minus 4ac equals to 0. So that is negative 2 whole square minus 4 into 1 into r minus 15 is equals to 0. This is 4 minus 4 times r minus 15 is equals to 0. Negative 4 r minus 15 is equals to negative 4. Negative 4 cancels. R minus 15 is 1. Therefore, r is 1 plus 15, which is 16. So R is 16, that is good. P is negative 2, Q is negative 15. This is also done and dusted. And this one was from which exercise? Exercise B. So that was a nice question, inequality. Now, what is so special in this one? This is almost completed square form. Now, remember, we cannot compromise on the standards. When we talk about straight line, y is equals to mx plus c, that's a gold standard for getting gradient. Y minus y1 is equals to mx minus x1, that is another gold standard. Y is equals to A, x minus h whole square plus k. That is the gold standard for completed square form. X minus h whole square, y minus k whole square is r square. That is the gold standard for the circle equation. Now over here, what's the issue? The issue is this, that the coefficient of x should be 1. So what should we do? Now let me do these two things separately. Now let me add a page over here. And let me first get rid of the second part, because second part has to be done normally. So now in the second part, it says hence or otherwise. We will just take the option of otherwise because that is easy. Find the set of values of x satisfying this inequality. That's a normal inequality, nothing special. Don't link it to the completed square form because we have a categorized things. Quadratic inequality, factorization is a must. So 4x square minus 12x minus 7 is greater than 0. 4 into 7 is 28 and 14 into 2. 4x square plus 2x minus 14x minus 7 is greater than 0. 2x, this is 2x plus 1 minus 7. 2x plus 1 is greater than 0. So this is 2x plus 1. 2x minus 7 is greater than 0. Let me draw a number line over here. Let me draw a quadratic curve over here and just mark the roots. So plus 1 becomes negative half. And this becomes plus 7 over 2. And we are interested in greater than 0, a region above the x-axis, two separate region, two separate inequalities, extreme right, extreme left, extreme right, extreme left. X is greater than 7 over 2 and x is lesser than negative half. So this is the answer for this one. And they have given so many answers. Okay, so x is greater than this thing, x is this, allow. I don't know why are they allowing it. That's a good question. So that is the answer for this particular part. Second part is a separate question. It's about quadratic inequality, the usual traditional way. We factorize, and once it's factorized, we draw a sketch. Drawing a sketch is a must, and based upon the sketch, we write down the answers. Now, people, that is what you need to focus, that whatever methodology that I teach you for a particular question, just apply that. Don't be adventurous. Now, coming back to this one. Now, this particular one, just first do it the normal way. So 4x square minus 12x, there is no constant. So let me just write a 0 over here. It looks beautiful. So this is 4 common. That is x squared minus 3x plus 0. That is the first step. That is, make sure the coefficient of x squared is 1. 4 as it is, x squared minus 3x plus bracket square minus bracket square. Even though it's a 0, just do it for the sake of writing. Add and subtract square of half the coefficient of x, negative 3 over 2, negative 3 over 2. Rewrite the first three terms as a perfect square, that is x minus 3 over 2 whole square. Simplify the rest, that is 9 over 4. And remember, there is a 4 on the outside. Now multiply throughout by 4. That is 4x minus 3 over 2 whole square minus 9. This is the completed square form. This particular step, that is the gold standard. That is y is equals to a x minus h whole square plus k. That is the completed square form. But they're not asking that. They want the 2 to be inside. Now, how did it slip on the inside? It slipped using the process of indices. Now, in indices, we know that a power m into a power n, that is a m n, if the powers are same. So, hold for a second, this is a power m into b power m, that is ab power n. Okay, I was writing the other rule, not the other rule, this one. So can I write 4 as 2 square? Yes. x minus 3 over 2 whole square minus 9. Now this is just like this. This is 2 square. This is this bracket square. So now the powers are equal. So what should I do? Multiply, take the power common. So this is 2 bracket x minus 3 over 2, the whole thing square, nothing to do with the 9. So now this 2 will multiply with these two. So that is 2x minus 3 whole square minus 9. Now it's in that form. Which form? 2x plus a whole square plus b. This is 2x plus a whole square plus b. Yes, a is negative, so a is negative 3. And b is negative 9. We just have to write in this form. We just have to write in this form, and that is the answer. And of course, you can copy it all once you'll be watching the video once again, and you can comfortably copy it down. So now this thing is also done and dusted. Let's complete the square, maybe another question of the same type. So now this is circular measure plus completed square. What a beautiful combination. A piece of wire of length 24 centimeter is bent to form the perimeter of the sector of a circle of radius r. Draw a small diagram. There is no harm in it. So that is like a curvature. And then draw two lines like this. One line, the other line. Okay. So now let's start labeling it. Radius is r. Radius is r. No mention of angle, but you have to use it yourself. And this is s is equals to r theta. So now for the first part, the perimeter is r plus s, which is 2r plus s, which is 2r plus r theta. How much is the perimeter? That is 24. This is equation number 1. So now you want to prove the area in terms of r. That means get rid of theta. That is why they did not bother mentioning it. So in other words, 24 minus 2r divided by r is theta. That is what you're looking for. Now, what about the area? Area is half r square theta. That is half r square. And what is theta? Theta is this green thing. That is 24 minus 2r divided by r. So now this r square gets cancelled. This r gets cancelled. There is this r over here. There is this 2 over here. So this is r on the outside. 24 divided by 2 is 12. 2r over 2, that is r. And they are leaving the answer after multiplication. 12r minus r square, that is a. Is that the answer? Yes, that is the answer. So question number 1, that is a combination of circular measure, two equations, perimeter, area, and that's how things are done. Express a in this form. So now we want to express it in the completed square form. So therefore, negative r square plus 12r. This is negative 1 common. This is r square minus 12r. Add a 0 if you want. And then even if you take a minus 1 common, 0 is unaffected. Negative 1 r square minus 12r plus bracket square minus bracket square plus 0. What goes inside the bracket? Half the coefficient of r, which is minus 6, which is minus 6. Rewrite the first three terms as a perfect square. That is r minus 6 whole square. What are we left with? This is minus 36. And don't forget, there is a minus 1 on the outside. So this is minus r minus 6 whole square plus 36. And how they have written it? They have written a minus r minus b whole square. So they have written a minus r minus 6 whole square. This is a minus r minus b whole square. So if you want a and b separately, what is a? 36. What is b? 6. That is simply comparing coefficient. Double check. This 36 is your a. And this is r is your r. And this is minus 6 is your minus b. And this square is your square. And this negative is your negative. So just do comparing coefficient. A is 36, B is this. They are asking us to write in this form. They are not asking for A and B separately. I have done something extra on my part. So now this thing is also done and dusted. Now this question, this is, first of all, I need to explain to you that this weird symbol, what does it mean? Now remember that on Thursday, we got started with functions. And let me just write it properly. Okay, now what it means is that for all real values of x, that is the meaning of this word. That is the symbol. The function is defined where a and b are constants, the solution of the equation are such and such. Now, this is the same type of question that you just saw about the roots. So now fx is equals to x squared plus ax plus b. And 1 and 9, these are the roots of the equation. So this and this, the coefficient of x squared is 1. So I can write y is equals to, or fx equals to a, the coefficient of x squared is 1, x minus p, x minus q. That is 1, x minus 1, x minus 9. Expand. X squared minus 9x minus x plus 9, that is x squared minus 10x plus 9. Compare it with this. So ax is negative 10x. So a is negative 10, b is 9, b is 9. What are they asking? Find the values of a and b. So this is negative 10 and this is positive 9. That is good. Of course, you can also solve it simultaneously. The coordinates of the vertex of the graph. Now, first of all, fx is x squared minus 10x plus 9. Now, if they are asking about the vertex, that means the turning point. So vertex means turning point. Also, later, we will call it stationary point. Method 1, that is completing square. Method 2, that is factorized. Based upon the factorize, we will get this thing. Let me do it both ways. First thing, fx is equals to x squared minus 10x plus bracket square minus bracket square plus 9. What goes inside the bracket? Half the coefficient of x, negative 5, negative 5. This becomes x minus 5 whole square, and this is negative 25 plus 9. This is x minus 5 whole square. Negative 25 plus 9 is negative 16. Write the gold standard underneath it. A x minus h whole square plus k. When nothing is written over here, that's 1. So that's the shape of the graph. Minus h is minus 5, h is 5, k is negative 16. That is the coordinates of the turning point, vertex, stationary points. Another thing. Take the factorized form, x minus 1, x minus 9. Fx is x minus 1, x minus 9. X coordinate of turning point is halfway between the roots. So 1 plus 9 is 10. 10 divided by 2 is 5. That's the x coordinate of turning point exactly over here. Y coordinate of turning point, plug in the equation. So this is 5 minus 1, 5 minus 9. 5 minus 1 is 4. And 5 minus 9 is negative 4. 4 into negative 4 is negative 16, exactly over here. So 5 and negative 16, that's the coordinate of the stationary point, also known as vertex, also known as turning point. All good? This guy's quadratic equation, this was not given in homework, but let me solve this thing out for you. The diagram shows the curve and the line intersecting at these 2 points. So now, first of all, this is the line that is going this way. That is y is equals to 2x. That's y is equals to 2x. And the curve, that is this one, the red one, that is the curve. That is the curve going like this. That's the curve going like this. So they are intersecting at 3 points. One of the point is the origin. The other 2 points are A and B. Now it says, show that the x coordinate of A and B satisfy this equation. Now this is a question, a scenario of simultaneous equations, okay? Because that's the curve. 2x power 5 plus 3x cube is equals to 2x, equated to the line. Do not divide. 2x power 5, 3x cubed minus 2x is equals to 0. Take x common out. That is 2x4 plus 3x squared minus 2 equals to 0. That means x is equals to 0. That is the origin. When x is equals to 0, y is equals to 2 times 0, which is 0. So O is the origin. That was very, very obvious. But show it. But still show all steps. Okay, that's the first thing. Now, what are you left with? You are left with this thing that's right over here, this thing on the inside. So this green line, that is 2x4 plus 3x squared minus 2 equals to 0. That will give me coordinate of A. That will give me coordinate of B. Let m is equals to x squared. M squared is x power 4. So this is 2m squared plus 3m minus 2 equals to 0. This is 2m squared plus 4m minus 2 equals to 0. This is 2m plus 2 minus 1m plus 2 equals to 0. M plus 2, 2m minus 1 equals to 0. Let me add a page. So therefore, m plus 2 equals to 0. M is negative 2. M 2m minus 1 equals to 0. M is positive half. But what is m equals to? But m equals to x squared. But m equals to x squared. So x squared is negative 2. No solution cannot take square root of a negative number. X squared is equals to half. Therefore, x is plus minus square root of half. That is x equals to plus minus 1 over root 2. And what are they asking? They are asking the coordinates. That means the y coordinates also. So x is negative half, negative 1 over root 2. And x is positive 1 over root 2. Now see for yourself. The x coordinate of A is negative. So this is x is negative 1 over root 2. The x coordinate of B is positive. So x is positive 1 over root 2. What the idea? The x coordinate is negative for A, x coordinate is positive for B. And we need the corresponding. So just use the simple equation y is equals to 2x. But y is equals to 2x. So y is equals to 2 times negative 1 over root 2. And over here, y is equals to 2 times positive 1 over root 2. So this is negative 2 over root 2. This is positive 2 over root 2. I can rationalize and this will become negative. Let me write it like this, over root 2. Let me write it like this, root 2 over root 2. Basically, what I have done is that I have broken down 2 into root 2 root 2. I have broken down this 2 into root 2 root 2. So what am I left with? I'm left with y is equals to negative root 2. Therefore, the coordinate of A is negative 1 over root 2 comma negative root 2. And similarly, the coordinate of B, this is y is equals to positive root 2. So coordinate of B is positive 1 over root 2 comma root 2. So many roots. This they have written in this form. And another way is this thing, rationalization. So 2 root 2 over 2, which is root 2. So this is root 2. Okay. This is B, positive, positive. This is A, negative, negative. All good? So that is how this thing is done. And that is where the buck stops. And that was a wholesome overview of quadratics from all aspects. Take care, people.